Chapter 6, Trigonometric Ratios. Some prerequisites of IGCSE, sine, cos, tan. Some people have curly brown hair through proper brushing or so katua. Sine theta is perpendicular over base. Let me write it here. So sine theta is perpendicular over hypotenuse, cos theta is base over hypotenuse, and tan theta is perpendicular over base. Cosine rule. IGCSE a square equal b square plus c square minus 2bc cos a. We should just move on to the exercise. Examples. Let me see. Exam style question. Okay, this is it. Question number 17. The diagram shows three cargo ships A, B and C which are in the same horizontal plane. Ship B is 50 kilometers due north of ship A as given in the diagram, and ship A is 70 kilometers from ship A at a bearing of 20 degrees. Calculate the distance between B and C. So if I have to calculate this distance, I can see we have two sides, one inclusive angle and this side is unknown. So I'm using cos rule for this and writing x squared is equals to 50 square plus 70 square minus 2 into 50 into 70 into cos of 20. Using calculator, this is 50 square plus 70 square minus 2 into 50 into 70 into cos of 20 all at once is 822. X square is equals to 822.15 square root both sides and we get BC, that is 28.67, writing 28.7 kilometers. B says calculate the bearing of ship C from B. So bearing is always clockwise and from north. So this is the angle we need to know. So in order to do that, we can first find this angle and then we'll subtract it from 180. So we have all three sides and we can use this pair and this pair with sine rule. So this is sine of B divided by 70 is equals to sine of 20 divided by 28.7. So cross multiply, sine B is equals to sine 20 by 28.7 into 70, which is sine 20 by 28.7 times 70. I'm getting 0.83. So sine inverse of 0.83419. Shift sign of the number in calculator is 56.5. So this is 56.5. Now you do realize that this is actually obtuse. If I'm getting 56.5, this angle right here is obtuse, so it should be 180 minus 56.5, which is 123.5 degrees. So 123.5 degrees. This above angle is so the bearing is always 3 digits before the decimal. This is our bearing of C from ship B. Any confusion? Again moving on from the examples and exercise, skipping all the way to reach exam style questions. Okay, this is it. Question number 11 says, in triangle ABC, AB is equals to x, BC is equals to 4 minus x, and BAC is y, and angle BCA is 30 degrees. Show that sine y is equals to this. So let me sketch this triangle quickly. A rough sketch A, B, C. It could be anything, isosceles, scalene, or equilateral. And AB is x, BC is 4 minus x, BAC, this angle right here is y, and BCA is 30 degrees. So we have to show this. So we can see that we have these two pairs which are known. Angle and side, we use sine rule. 4 minus x is side over sine y is equals to x over sine 30. So the question right here says sine y. To make sine y my subject, so sine 30, when I punch this in calculator, I get 1 by 2. So 1 by 2 into 4 minus x is equals to x sine y. Now we take this x on the other side. And 1 by 2 into 4 minus x over x is equals to sine y. And we are given that sine y is equals to 1 by square root 2. So 4 minus x over 2x is equals to 1 by square root 2. And we have to make x the subject. So we just keep on rearranging into square root 2 is equals to 2 on the other side. This is 2x. 4 square root 2 minus x square root 2 is equal to 2x. Taking x on a right hand side is x square root 2. Taking x as common is 2 plus square root 2, and 4 square root 2 over 2 plus square root 2 in the next step. 4 square root 2 over 2 plus square root 2 is equals to x. To make that shape, I am going for rationalizing. So x is equals to 4 square root 2 over 2 plus square root 2 into 2 minus square root 2. Do you understand rationalizing? So when we multiply these two, I get 8 square root 2. When you multiply the next two, you get minus 8 by a plus b into a minus b is a square minus b square. So we take out this as common. This is 8 square root 2 minus 1 by 2. 2 1 times, 2 4 times. So 4 square root 2 minus 1 shown. Question number 12. A surveyor wants to determine the height of a building. She measures the angle of elevation of the top of the building at 2 points 15 meters apart on ground, as shown in the diagram. 40 degrees 15 meters apart and the top of the building. Use this information to determine the height of the building. So if I just say that the height of the building is h, and I say that this unknown space is x, so we are going to write, let us use tan of 40 is perpendicular over 15 plus x, and with 52, this would be tan of 52 is equals to h over x. and we have to determine the height, we can use these two equations to solve for h or solve for x. So if I just replace this x, that would be x over tan 52. Substitute on the other side, that is tan 40 is equals to h over 15 plus h by tan 52. So the only unknown in this equation now is h. Now we go for multiplication. I'm converting it into numbers, decimals. Tan of 40 is 0.839 equals h over 15 plus, and I'm writing this 1 over tan 52. 1 divided by tan 52 makes it 0.781h. We multiply 0.839 times 15 is 12.585 plus 0.839 into 0.78 is 0.65442. h is equals to h. Now we take this on the other side and subtract from 1, and we get 0.34558. Now divide this number on the other side to get h, that is equals to 12.585 divided by the number is 36.4. And all readings were in meters, so height is 36.4 meters. Question number 6. A crane arm AB of length 80 meters is anchored at a point B at an angle 40 degrees to the horizontal. So we can see A, we can see B. This is 40 degrees, that is 80 meters. A wrecking ball is suspended on the cable of length 60 meters from A. I can see that 16 diagram. Find the angle x through which the wrecking ball rotates as it passes the 2 point levels over the base of the crane arm at B. So we have to find this x. So I know that this is 60 and this is 60 as given in the question. So I have this 40, I have this 60 as in pair. If I use these two to find this unknown angle theta, I'm using sine rule. Sine theta over 80 is equals to sine 40 by 60. So sine theta is equals to a cross multiply sine 40 by 60 into 80. So sine 40 divided by 60 into 80 is 0.857. Sine inverse of 0.857. And getting 58.98 approximately equal to 59. Now understand that this is already obtuse, so this opposite side should be 59, and 180 minus 59, this side is 180 minus 59, this side is actually 121. So that is isosceles. This is 59 59 both, and x is equals to 180 minus 59 minus 59, which is 62 degrees. B part says write down one modeling assumption you have made. So again, this whole line is a straight line. All the lines are straight. This is isosceles and they are in same level. Question number 5. In triangle PQR, PQ is this, PR is this, and QPR is this. The area of the triangle is A. Show that area is this. So let's make a quick sketch. PQR. PQ is x plus 2. PR is 5 minus x. And QPR is 30. Area of the triangle is capital A, and show that. So we use the formula area. General form is 1 by 2 AB sine of C, which means two sides and inclusive angle. So area is A, 1 by 2. We have these two sides, 1 and 2. So x plus 2 into 5 minus x, and inclusive angle is 30. So sine 30. And we simplify. Sine 30 is 1 by 2. So 1 by 2, x into 5 is 5x minus x square. 2 into 5 is 10. 2 into x is minus 2x. And sine of 30 is 1 by 2. 1 by 2 into this first 1 by 2 is 1 by 4. Simplify this 10 right here. Then we have 5 minus 2 is 3x and negative x square shown. B part says use the method of completing the square or otherwise to find the maximum value of area and give the corresponding value of x. Okay, he's already given you the hint that use completing square method. The other would be differentiation. So once we do that, we can use that method as well. So it is 1 by 4. When we solve for this, I'm bringing this negative sign outside and writing it as minus 1 by 4 x square, or just let me write it as it is. This is 1 by 4 already, that is negative x square plus 3x plus 10 minus 1 by 4 x square minus 3x minus 10. When we go for completing square, this is negative 1 by 4 x square minus 3x. So half of coefficient of x squared. So plus 3 by 2 squared minus 3 by 2 squared minus 10. We keep on working and completing the square. X is copied, negative sign is copied, 3 by 2 is copied, whole square. This is minus 9 by 4 minus 10. And then we make use of calculator. This is 9 by 4 and 10, that makes it negative 49 by 4. Outside this is minus 1 by 4 x minus 3 by 2 whole squared. Now I'm bringing this negative 1 by 4 inside. 1 by 4 x minus 3 by 2 whole squared, negative negative is positive, 49 by 16. So the demand was use the method of completing square form done, or otherwise to find the maximum value of a. So it is a sad face, and the turning point of which is x 3 by 2 and y 49 by 16. So the maximum value is 49 by 16. Question 6. In triangle ABC, quick sketch. ABC, AB is x, AC is 5 plus x, and BAC is 150 degrees. Now that I have seen it, if it is 150, a good sketch makes a better understanding. So ABC, this is obtuse, and we know that at 150 or 30, it will give the same answer as sine theta is equals to sine 180 minus theta. So given that the area of the triangle is 3 by 4, show that x satisfies this equation. area is already given. So area is equals to 1 by 2 first side into second side into sine of inclusive angle, and area is 3 by 4, that is 4 3 times 12 13 14 15 by 4. So this is 5x plus x square, and sine of 150 is 1 by 2. So 2, this is 15 by 4, this is 1 by 4, 5x plus x square, we get rid of this 4 and we rearrange the equation. 15 equals 5x plus x square, that is x square plus 5x, bring 15 to this side is minus 15, is equals to 0. So shown. B part says calculate the value of x, giving you answer to 3 significant figure. So if it is already in 3 significant figures, we know that we are not going for midterm breaking, and we can apply quadratic formula. Minus b plus minus square root b square minus 4ac divided by 2a. So minus b plus minus square root b square minus 4a is 1 and c is negative 15 by 2a. Making use of calculator, first with the positive number, this is minus 5 plus square root 5 square minus 4 into 1 into minus 15 by 2. This gives me 2 and to 3 significant figures it is 2.11 rounded, and with the negative number this gives me a negative answer, that is 7.11 again. And calculate the value of x. This one is rejected as we know that x is length and that cannot be. Question number 13. In the triangle ABC, question 13, A, B, C. AB is equals to 14 centimeters, BC is 12, CA is 15. Find the size of angle C. So we can use cos rule. So cos C is equals to 14 square minus 12 square minus 15 square divided by minus 2 into the two inclusive sides, which are 12 and 15. Cos of C is equals to, using calculator, 12 square minus 12 square minus 15 squared by minus 2 times 12 times 15, and this is 173 by 360, and C is equals to cos inverse of the number, which leaves an answer 61.3 up to 1 decimal place and 3 significant figures. B part says find the area and leave your answer to 3 significant. So this angle is 61.3. For area, we use the formula area is equals to 1 by 2, 15 times 12, and sine of angle between the two sides. So 1 by 2 into 15 into 12 into sine 61.3, that is 78.9 centimeter square. Question 14. A flower bed is in the shape of a quadrilateral as shown in the diagram. Find the sizes of angle DAB and BCD. So DAB, this right here is again cos rule. So cos of A is equals to 5.9 square minus 4.2 square minus 2.1 square by minus 2 into 4.2 into 2.1. So A is equals to cos inverse of this thing, and let me simplify. 5.9 squared minus 2.1 square minus 4.2 squared over minus 2 into 4.2 into 2.1. So this is negative 319 by 441. Shift cos of answer, I get 136.3. 136.3 degrees. And BCD again is cos rule. So angle at C, let me write this directly. So cos inverse of 5.9 square minus 7.5 square minus 3.5 squared divided by minus 2 into 7.5 into 3.5, and punching this directly in calculator. 5.9 square minus 7.5 square minus 3.5 squared by minus 2 times 7.5 times 3.5 is 50.1 degrees. B part says find the total area of flower bed. So total area, we have two triangles. The left one is 1 by 2 AB sine C, 4.2 times 2.1, 4.2 times 2.1, and angle between them is sine 136.3 plus on the other side 1 by 2, this is 7.5 times 3.5 times sine, angle between them is 50.1. 0.5 into 4.2 into 2.1 into sine 136.3 plus 0.5 into 7.5 into 3.5 into sine of 50.1, and I get an answer of 13.1 meter square. Last says find the length of diagonal AC. Length of diagonal AC. Okay. Now for this, I'm going to find two angles and then I will use cos rule. This is the first angle ADB, then the second angle is BDC, and then I'll have this complete angle and use cos rule. So for ADB, I am using this triangle on left, which is 4.2, 2.1, 5.9. We have this angle 136.3 and this unknown angle could be found. So let's write sine of theta unknown divided by 4.2, which is opposite to it, making a pair. These two are making pair, and then these two. So sine of 136.3 divided by 5.9. Theta is equals to 4.2 into sine 136.3 by 5.9, and theta should be equal to sine inverse of this answer, which is 4.2 into sine 136.3 divided by 5.9. This is 0.491, and shift sign of answer, we get 29.45, so that is 29.5. This is 29.5. Now on the other side, (5.9), 7.5, 3.5, we have this angle which is 50.1, and this could be found theta. So sine theta by 7.5 in pairs is equals to sine 50.1 by 5.9. So sine theta is equals to 7.5 times sine 50.1 by 5.9. Theta is equals to sine inverse, and 7.5 times 50.1 divided by 5.9 is 0.975. Sine inverse of answer is 77.2. So this is 77.2. Now I have to find AC. AC is unknown. AD is 2.1. DC is 3.5, and this complete angle is sum of 77.2 and 29.5, which is 106.7. So AC using cos rule, AC square is equals to 2.1 square plus 3.5 square minus 2 into 2.1 into 3.5 into cos of 106.7. So AC squared is equals to 2.1 square plus 3.5 square minus 2 into 2.1 into 3.5 into cos of 106.7. That is 20.884 square root. Both sides. AC is equals to square root of answer, that is 4.5699, approximately equal to 4.6 meters. Question 15, ABCD is a square, so we know all these sides are 10 each. CED is obtuse, we'll use that. Find the area of the shaded region. So if this is 40, this is 50, because this is 90, 90 minus 40 is 50. And I'm using this pair to find CED. So sine, I'm writing it only E, sine E over 10 is equals to, on the other side, we have sine 50 over 8. So E is equals to 10 sine 50 by 8 and sine inverse of this. So 10 sine 50 by 8 and shift sine of answer. This is 73.2. E is equals to 73.2, but it is given in question that it is obtuse. Therefore, E is equals to 180 minus 73.2. Calculator always gives you acute angle. So this angle is actually 106.8 degrees. 106.8 degrees. Now we can solve for other sides. So if I now solve for side EC over this angle is now known, because 180 minus 50 minus 106.8, we get 23.2. Sine of 23.2 is equals to 8 over sine 50. So EC is equals to 8 sine 23.2 over sine 50. So 8 sine 23.2 divided by sine 50, I get 4.11. So EC is, let me change colors, 4.11. So going for EB, we have side EC, we have side BC, we have this angle, so we can find EB using cos rule. So EB squared is equals to 4.11 square plus 10 square minus 2 into 4.11 into 10 into cos of 40. So 4.11 squared plus 10 squared minus 2 into 4.11 into 10 into cos of 40, and I get 53.9. Square root of that is 7.34. 7.34. So EB is 7.34. This length 7.34. Now when I have this length, I can go for angle B. For this angle B, I have this opposite side which is 4.11. So sine B over 4.11, one pair, and the other pair is this angle 40 degree and 7.34. So sine of 40 and 7.34. So sine B is equals to 4.11 into sine 40 divided by 7.34. This is 0.3599, and B is equals to sine inverse of this, that is 21.09, makes it 21.1. So this is 21.1. So I have the angle inside. ABE is 90 minus 21.1. So 90 minus 21.1 gives you 68.9. Now for the shaded region, I have this side 10, I have this side 7.34, I have this angle 68.9. So area is equals to 1 by 2 first side into second side into sine 68.9. So 1 by 2 into 7.34 into 10 into sine 68.9, that is 34.2 unit square, and this was centimeters, centimeter square. Someone give me a break.